Hey folks, I want to talk to you in this episode about number order and the absolute value. And there's not a whole lot to learn with the definitions because they're kind of junky looking. But if A is, and this is the less than symbol, B, then that just means A is to the left on the number line than B. So if we were to actually draw a number line in here, right, and I put A goes in the direction that this thing is pointing at, right? So A is pointing to the left. So A is going to be over here of B. If A equals B, then that just means they're at the same spot, right? So if I were to draw those two on the number line, they would just be at the same location. Those lines would be on top of each other. And then A is pointing to the right. So on this one, A is to the right of B because that's the direction that arrow was pointing. So let's check out some examples here. I need to add in my inequalities, right? And inequalities are just the less than, greater than, and equal to. So this is, I read left to right, so something is less than this. And my next one is something is greater than the thing on the right. And then this is, of course, equal. So 6, is it less than or greater than 8? Well, it is less than. The alligator mouth, as a lot of teachers say, want to eat the bigger thing. What about 2 and 5? Well, 5 is bigger than 2, so the alligator wants to eat the 5. 5 and 9, we want to eat the 9. Negative 4 and 0, this is kind of a tricky one for some people, but negative, right, having negative $4 is way worse than being broke and just not having any dollars. So alligator wants to eat 0. That's bigger than having negative 4, right? That's like puking for an alligator. So 0 or 3, I actually want to eat the 3 because it's bigger. Let's check out some more complicated examples here. But first, absolute value. Absolute value is just my distance from 0. So if I wrote that the absolute value of 5, well, that actually means if I were on a number line, here's my 0, here's 5, over here's negative 5. Absolute value of 5 means that I could be at negative 5 or positive 5. It could be either one because when I come out of this, it's always going to be a positive number. So here's some examples. I need to graph x equaling 2, but it's an absolute value. So I come over here at negative 2, and I come over here at 2, put my 0 in the middle. So I am at a solid dot at both of these locations. And since I'm just equal to a specific number, I have to just put 2 dots. There's no line going on here. The next one's a little bit different. X is bigger than 2. Well, I need to put a 2 on here. Put a 0 over here. X is greater than 2. If I have my variable on the left, this inequality is actually pointing in the direction my arrow goes, which is kind of neat. So I'm going to do an open dot for right now, and then I'm going to draw that this arrow goes to my right. But now I have to figure out, is that an open circle here, or is it a closed circle? And it is, in fact, open because I am strictly greater than. X is greater than 2. If it were x greater than or equal to 3, we'll say, then I would get a solid dot there. If it's equal to, then I get a solid dot, and x is on my left. Okay, so this arrow is pointing in the direction that my arrow is going to go, so it goes to the right. All right. So if if a equals 3, b equals 6, find a number c such that a is less than c is less than b. If you look at this, it really just means c has to be in the middle, right? That's all that's really saying. So let's plot these on here. Here's 3, over here's 6, and I want c to be in the middle. Well, that's all of these numbers in here, right? You know, there's a 4 and a 5, and I didn't space my numbers out right. Okay, so it's this squiggly line here, but what about at my ends? Are these open circles or closed circles? They're open because these are not equal to. They're strictly greater than or less than. I cannot put a solid dot because I'm not equal to. All right, so now I actually have to evaluate, so I need to spit out a number for this. And you can plug this into your graphing calculator. You can plug it into Desmos. It all spits out the correct answer most of the time. So negative 3, but that's my distance from 0. How far away is that from 0? That's 3 away. All right, 7. How far away is negative 7 from 0? Well, it's just 7 away. And I'm actually just going to bring down this outside 3 because I'm simplifying just my absolute values first. So that's just going to come down. What's the absolute value of 4? Well, it's still just 4 away from my 0. And you'll notice I wrote multiplication here in the middle now between that 3 and that 4. Because if I put a 3 in front of absolute value or a 3 in front of just a set of parentheses, then I'm multiplying there. Now, what is 3 times 4, right? I have to remember PEMDAS, which says to do inside my parentheses first, don't have any. Exponents, don't have any. Multiplying, I do. So what is 3 times 4? 12. And now I can move on to my addition. And what is 7 plus 12? And that is 19. Off to the right here, I have to do my parentheses. My parentheses, my absolute values are treated at the same time. So let's simplify inside my absolute value first. So that negative, I'm just going to have it come down. And what is 8 minus 2? Well, that's 6. Still inside my absolute value. Now, let's pull that 6 outside of my absolute value. So I'm just going to carry that negative down. What is the absolute value of 6? How far away is 6 from 0? Well, it's just 6 units away. It's always going to be a positive number when I come out of there. But this negative out in front didn't go away. Okay, it is outside my absolute value, so it just stays down here. And then there's nothing else to do. There's no more simplifying to have happen. That's just my answer. Now I have to solve these things. And this can be a little bit tricky because I actually have 2 different things I need to solve for. When my absolute value is alone. So first, get my absolute value alone. And it is. It's not on the other one. It is here. There's nothing being added to my absolute value. There's nothing being subtracted or multiplied or divided to my absolute value part. Don't care about inside yet. I just care about the outside of it. And when that is true, I split it into 2 cases. Or you like to maybe think of it like 2 problems, right? All of these are going to become parts A and part B, part 1 and 2, whatever you like. So I have a positive x minus 2 equals 3, and I have a negative x minus 2 equals 3. On the one on the left, nothing to do except add my 2 over, and then x equals 5. The one on the right, there's stuff I have to do. I'm going to distribute my negative sign in. So I get negative x plus 2 equals 3, right? There's double negatives in front of that 2 now. And I want to solve for x, so I'm going to add my x over. Now I have 2 equals 3 plus x. I still need to get x by itself, so I need to subtract my 3 over. And I get negative 1 equals x. Both of those actually are my solutions. So I could write this like x equals, and then I could do squiggly bracket, negative 1, and a 5, and then end with a squiggly bracket. And that's how a lot of computer programs are going to want this answer. All right, let's go off to the right now. I need my step 1, get my absolute value alone. There's a 3 in front of it, so I'm going to divide by a 3. So now the absolute value of x, I don't know why I wrote an A, equals 2. Now my absolute value is alone, so I need to split into my 2 problems. So I have a positive x equals 2, and I have a negative x equals 2. The positive one, I'm just done. I'm just going to get rid of my positive sign out in front, and I'm going to get rid of my parentheses. Nothing to do with those. The one on the right, there's that negative. If I distribute that in, I get negative x equals 2. But I don't want a negative x. I want a positive x. So I'm going to multiply both sides by a negative 1. And I get that x equals a negative 2. So I got x equals positive 2 and x equals negative 2. And again, I can write that all together. A negative 2 and a positive 2. Awesome. That's my answer for this one. This is my answer for the last one. And that's it, folks. Thanks for watching, and I hope this was helpful.